Hi everybody, it's Swordtash Master Tutor, and this is part 2 of powers or indices or order or whatever you want to call it, and we're going to be looking at power of a power, fractional indices, what's x to the power of 1 and x to the power of 0. The previous video has covered stuff like what's x to the power of 3 times x squared, and it's that rule that becomes x to the power of 3 plus 2, or x to the power of 5. If you need to review that, then just go and have a look at that. And we've also had x to the 7 divided by, so it's the division of indices, x to the power of 2, and that worked out as x to the 7 minus 2, which equaled x to the 5. Hey, how spooky is that? And we also had x to the power of minus 1, which is the negative indices, and that became 1 over x, and that could have even been a number, 6 to the minus 1, which would become 1 over 6. That's just a very quick revision of the previous video. So the first one we're going to do is power of a power, and basically what that looks like is if you've got something in a bracket, so I'm going to use a y in this case, we'll make it y squared, and they call it raised. Now the way I look at it is that if I've got the power there, hang on, I'm trying to be clever here, and I raise the power up, because it's usually written like that, that's raising the power. Now you'll remember from the previous video that in indices, whatever you see is not what you get. Well, the only sort of, forgetting this bit and this bit for a second, all I've got left is these two things here, and they sort of collapse in on each other, and I always think they end up looking like a multiply sign, and that is exactly what you do. And again, it only happens to the powers, so this becomes y to the 2 times 3, which equals y to the 6. Let me give you another example. If I have t to the 4 raised to the power of 5, then that would be t to the 4 times 5, which equals t to the 20, and that's the power of a power, or raised powers. And the next one is fractional indices. So this one you just got to sort of learn. X to the power of a half equals the square root, and the 2 goes there. That's the proper way of writing square root of x. A great example of that would be 4 to the power of a half, that equals the square root of 4. Well, normally we'd just write square root of 4 like that, but square root of 4 is 2. You can sort of take that on, because whatever the number here is always repeated here. And so if I had, I'm trying to think, there we go, what is 64 to the 3rd? Well, that means it's the 3rd root, i.e. the cube root of 64, and that is 4. Let's give another example. What's 8 to the 3rd? Well, that's the 3rd root of 8, which equals 2. I can take that even further, and I'm not necessarily going to know what the answer to these things are, but x to the 5th root, x to 1/5 is the 5th root of x. Now, what you suddenly begin to realise is that with all of these things, whatever is here appears here. So it's sometimes called the nth root of the number, and the way that we would write that is this. If we've got x to the 1 over n, then it will be the nth root of x So in other words, if I had if x equaled 9 and n equaled 2, I'd be rewriting this as 9 to the power of a half, which is the second root, or square root as we would most commonly have 9. Square root of 9 equals 3. And that's all it is. And now for just 2 that you're going to have to know. There is a long explanation. I ain't going to give it to you though, people. You're just going to have to know that x to the power of 1 equals x. Now you may recall in the previous video that we had that table, didn't we? X times x, that gave me x squared. X times x times x gave me x cubed, and that we had drawn a table out, 1, 2, 3, and that gave me the 3 or the 2 to give me the indices or power. Well, this is where that x to the 1 comes from, because if I had an x here, what power is it to? Well, if I follow what I've done here, it's got to be x to the 1, and that's it. Just so in other words, what I'm saying is, if you go into a shop and pay £5, well actually you're paying 5 to the power of 1, because that equals £5. £5 to the power of 1 equals 5. So x to the power of 1 equals x. 6 to the power of 1 equals 6. 10 to the power of 1 equals 10. I was going to say elephant to the power of 1 equals elephant, but that's being stupid, everybody. And then the final one is x to the power of naught. There is a long explanation, and I might give it separately, but x to the power of 0 is 1. In fact, anything to the power of 0 equals 1, 1, 1. 3,267 to the power of 0 equals 1. T to the power of 0 equals 1. It all equals 1. This has been Saltash Maths Tutor. Thank you for watching that very quick canter through part 2 of indices and powers. I hope you found it useful. If you have, then please post a comment and look at the other videos. I'm very happy to help at any time. Thank you.